Okay, now we're going to introduce you the graphical method. Solve LP by graphical method. Okay, and we're going to use this example. We try to maximize W equal to 3x1 plus 2x2. This is what we call the objective function. Subject to constraint 1, 2x1 plus x2 less equal to 4. Second constraint, 2x1 plus 3x2 less equal to 6. And x1, x2 are what we call non-negativity constraints. These non-negative constraints is what? Always in a LP formulation, because in real life decision, you don't know x1. Say x1 is number of window produced per week. You don't know the meaning of x1 equal to -3. Doesn't make sense. Okay? So in real life application or LP problems, we always have non-negativity constraints. That is, all the decision variable has to be what? Greater or equal to 0, or you say non-zero. Okay? And step 1, use graphical method, is we're going to plotting points and lines to determine the feasible region. Okay? And for that, we're going to begin with what? The boundary of the constraint 1. Boundary of what? Constraint 1. That is 2x1 plus x2 less equal to 4. Its boundary going to be 2x1 plus x2 less equal to 4. Okay? So let's see how we're going to plot the point on the graph. We know 2 points will uniquely determine a line. Okay? So the linear equation, the boundary of the feasible region is 2x1 plus x2 equal to 4. This is x1, this is x2. When you set x1 equal to 0, when this is 0, x2 is 4. And when you set x2 equal to 0, x1 is 2. And we know 2 points will uniquely determine a line. Okay? So when x1 is 0, x2 is 4. Okay? So this will be what? Will be very high, about here. This point going to be what? This going to be 0, 4. And 2, 0. When x1 is 2, x2 is 0. So we join what? The 2 point by a line. Okay? This is the line what we're looking for. Okay? This line is what? 2x1 plus x2 equal to 4. But this is a boundary. What we're looking for is what? Less equal to 4. So, how are you to determine the right direction? Because so far we don't know is this area or this area is 2x1 plus 4 less equal to 4. It's very simple, okay? In determine, okay, let me repeat one more time. We want to determine the constraint 1, okay? And the boundary of constraint 1, we find 2 points, 0, 4, 2, 0. 2 points will uniquely determine the line. So this is a line. But what bothers us right now is we don't know it's this area or this area. Upper right area or lower what? Left area is what we're looking for. Namely, 2x1 plus x2 less equal to 4. We don't know which one, okay? So in determining the correct region, if the origin is not on what? The boundary. We always use 0, 0 as a checking point. That is to say, two x2 plus x2, that's equal to 4. And you put 0, 0 here. That's origin. x1 equal to 0, x2 equal to 0. So 2 times 0 plus 0. This is 0. 0, of course, that's equal to 4. Okay? Then everything follow the same direction. Huh? Everything on the same direction of the line will have satisfied the constraint. This is the origin. And we put origin in the region, and we find what? Satisfy the constraint. So we know everything on the same direction will satisfy that constraint. Okay, so from the discussion, the lower left area is corresponding to what? This constraint, okay? This constraint. And similarly, we can find the boundary of what? Constraint 2. 2x1 plus 3x2 equal to 6. You first set x1 equal to 0. 2 times 0 is 0. 3 times 2 is 6. So x2 is 2. Similarly, when you set x2 equal to 0, x1 is 3. Okay? With these 2 points, we can determine what? We can determine the region we are looking for. Okay? So 2x1 plus 3x2 equal to 6. First one is 0, 2. 0, 2 is right here. Okay, this is 0, 2. I use a circle. 0, 2. And 3, 0. This is what? 3, 0. So I also use a circle. I join what? 2 points by a line. Okay? And the boundary of the first constraint, the boundary of second constraint, they will intersect what? At this point. Okay, they will intersect at this point. So we need to determine what? This point. Okay? Now, before we determine this point, let's look at what is the correct region. Okay, what's correct region for the constraint? Okay, for the 2x1 plus 3x2 less equal to 6. So when you put 0, 0 here, 2 times 0 is 0, 3 times 0 is 0. 0 plus 0 is what? 0. 0 is, of course, less equal to 6. Okay? So, this is the area what we're looking for. Okay? It goes this way. Same direction as what? As the origin. Okay? And then, this is x1 greater equal to 0. And this is x2 greater equal to 0. Okay? Greater equal to 0. So the intersection of the four constraints is called feasible region. Okay? So we can see it's look roughly like this. Okay? This one we know is origin 0, 0. This one here is what? Is 2, 0. And this one is this one is 0, 2. This one we don't know. Okay, we need to determine this one. Okay.